Welcome to this tutorial, and I'm going to show you how to create dynamic spring systems with geonodes using Blender. Start by adding a plane. After you've added the plane, let's delete all the geometry. Once you've done that, let's go to the geometry node editor, and I'm using the 3.5 Blender version as it has the geometry node capabilities to create a scene like this. We can press new. After you've done that, let's delete the group input. Here, let's search for position. And now we're going to create the shape that is going to define our spring. First, let's select the position node and add the math. In the math, let's select multiply, and we're going to drive the first value. The second value, let's set it to around 0.2, and you can always change that in the future. Now, as we've done this, let's select the multiply, connect the value to value, and here we're going to use trigonometry to drive the shape of our spring. We're going to go with cosine, and we're going to do the same thing for the sine as well. And this is going to create the spring shape that is stretched by the z-axis. Now let's add both greater than math nodes. Let's search it up, it's here. We're going to go with a threshold of around 0.5, and we're going to do the same thing for the up. Let's add a switch node, and here we're going to select float. Now let's connect the value to switch and add another math node. And here let's plug the output to value, and we're going to do the same thing for the sine version. Now let's combine both the coordinates. First, let's plug the value to value and also value to value. And then we're going to create the combine xyz, which is right here, the first for x and the cosine for y. Now for the z coordinate, we're going to create it with the multiply nodes. Let's plug the value here, going to set it to 0.2. Then the value goes here, and let's plug it. One mistake that I realized is instead of position, we should use index. Since here we're not really interested in the position of the curve, but rather the numerical points that we're using. Now going back to combine xyz, let's create the set position node. Now this part is going to create the curve itself. So it's going to create mesh to curve. Then we're going to resample the curve and subdivide as well. You might not want to use the subdivide, but if you want to, it's going to give more resolution for the mesh itself. And to create the geometry itself, let's create a mesh line node and set the z value to something very low, like 0.001. And the count we're going to drive with the geonode, so let's leave it like that for now. And now we can connect the mesh to, first let's create the set position node, and let's plug the mesh line to the geometry here. Now this concludes the shape and stretching of our spring, and now let's move to defining the shape itself. Let's create a position, and here we're going to separate the coordinates so that then we can use them to drive the set position node. For the z coordinate, the x and y coordinates are going to stay the same since we're not stretching on the x and y, we're stretching by the z. So in this case, let's create the point attribute, the attribute static. Let's get the geometry itself from the mesh curve right here. And now let's create the map range for the min and max value of this node. We're going to plug the min into from min and max to from max. And we're going to use the z coordinate for the value. Now let's create the color range itself. Color ramp. Result to factor, and here we're going to put the something around here. And we're going to define that later as we get the shape. And let's create the map range again to connect the to min to max with the new map range. So let's get the values from here. Make sure it's max to max and min to min. When you've done that, let's get the combine XYZ. So we can combine the z coordinate change with the constant x and y values. And to visualize the geometry itself, let's create the group input node. First, the value of the multiply, let's put it into the group input node. The wrong one. Put it here. And now you can see you have the value here. To display the geometry, let's create a curve to mesh. And here we're going to have the output. Now we need to connect the geometry of the input into the profile curve, and let's click fill caps. The reason why we're not seeing anything is because we have the group output node here, so let's delete it. And now you can see we have a turn of the curve already in place. Let's create the compression value, and we're going to take the true switch value of the cosine one, and we're going to drag it down into the group. Let's create the length and width control of the mesh. So let's select the true from here and go back to the group output, connect it here, and let's type length. And the same goes for the width. Now, depending on the coordinates that you were using, if you were using the x coordinate, maybe you'd have to switch the width with the length, but in our case, I'm going to keep it with these names. Now let's create the stretching itself. So I'm going to drop the index node, and here we're going to create the multiply math node. We're going to drive it to scale that stretching. And we're also going to use the position node, and we're going to separate the and we're going to keep the x and y coordinates constant. Now let's drop the combine node, and let's connect the y and x here, and z is going to go for the z. And now for the second value, let's use the map range. In fact, I think we need to switch the values because the map range value here is more important. So let's place the value here, and the value over here. And this combined XYZ vector is going to drive the position. Now as you can see, it's lifting up the curve. And to fix that, we have only one line. Let's connect the count to the group input. And I'm gonna call this group right here, and I'm gonna call it seed. Now if we increase the seed, as you can see, the spring is increasing in length, and it's also being stretched out. Right now the spring doesn't have any thickness, so let's add the curved circle to create that thickness. Now in here, let's drag the radius into the input. Here I'm going to rate it as radius, and we're going to connect the curve into the profile curve. Now as you can see, it adds some thickness. I also connected the from max value of the map range to drive the compression of the spring. As you can see, if I change the compression, it also changes the spring geometry itself, as you can see here. And what I like to do usually, if you're modeling a spring for a certain system, you can use the create lattice add-on to drive the shape of the spring. As you can see, it can stretch it or stretch it in by the y-axis. I don't recommend using the stretch by the z-axis since it's going to make it look very weird. I usually only use it for the y or x-axis. And once you've added that, you can also use the subdivision modifier to add some more resolution. Here's the overview of the nodes again. I changed the greater than value to 0.3. I think it looks more smooth with 0.3. Here's the overview. And hopefully you have the same results, and this concludes this tutorial. See you soon.